Ladies and gentlemen of geometry, this is 4.2 talking about properties of parallelograms. So what you need to be able to do is use properties to identify parallelograms and use algebra to solve geometric problems. Basically what we're looking at is what makes a parallelogram, and then how can I know if a shape is a parallelogram, and finally can I use that information to help me solve problems. So this is a parallelogram right here, okay? Parallelogram, you're talking about two pairs of parallel sides, all right, and then there's a whole bunch of things that are true about them, okay? So let's take a look here. So in parallelograms, okay, so you've got opposite sides, okay, they're going to be congruent, all right? That means this is equal to this, this is equal to this. All right, opposite sides are also parallel, okay, which is kind of marked here by the arrows. Those two are parallel, those two are parallel. All right, what you've also got to realize is opposite angles are congruent. Okay, so opposite angles now, not opposite sides anymore, opposite angles. So A and C would be congruent, B and D would be congruent. All right. So what else is true? Diagonals bisect. Okay, so if I draw the diagonals, they cut each other in half. We'll talk more about this later. You don't have to scratch up this piece of paper or this parallelogram. And finally, the last piece of the puzzle is that consecutive angles are supplementary. Supplementary, remember, equals 180. Consecutive angles basically means the next one. So like A and D, A and B, C and D, B and C. All those would be considered consecutive angles. All right, so these are kind of the high points. Let's break this one by one. So if a quadrilateral is a parallelogram, then the opposite legs are going to be congruent. Okay, if both pairs of opposite sides of a quadrilateral are congruent, then the quadrilateral is a parallelogram. So if I can somehow show or prove that these two are congruent, these two are congruent, then I can, and these two are congruent, then I can say, yes, it's a parallelogram. Likewise, if I know it's a parallelogram, they flat out tell me, yes, this shape is a parallelogram, then I can assume that that is true. So if a quadrilateral is a parallelogram, then the opposite angles are also going to be congruent. All right, so if the shape is a parallelogram, they tell me flat out, yes, it's a parallelogram, then the opposite angles are congruent. Likewise, flip it around. If both the opposite, that's supposed to be angles, if both pairs of opposite angles of a quadrilateral are congruent, then the quadrilateral is a parallelogram. All right, and then if a quadrilateral is a parallelogram, consecutive angles are going to be supplementary. We talked about that on the previous slide. Adds up to 180 degrees. So that means these two are 180, these two are 180, these two are 180, these two are 180. Every pair, every consecutive pair is going to add up to 180. So we've got opposite angles are congruent, opposite sides are congruent. So figure out what makes this a parallelogram. Well, 6x plus 3 has got to equal 15. So 6x equals 12, x equals 2. So when I put that in here, 4x minus 2y equals 2. So 8 minus 2y equals 2. Negative 2y equals negative 6. So y is going to equal 3. So x equals 2, y equals 3. Boom. And I know that because in order to be a parallelogram, these two have to be equal. These two have to be equal, so I just use that information to solve the problem. So figure out the values of x and y that make this a parallelogram. Well, this is going to be equal to this, all right, and these two are going to add up to 180. So I'm going to say y plus 10 equals 2y minus 40. All right, so a little subtraction. So 50 equals y. Okay, so if 50 equals y, that means that this angle is going to be 60 degrees. So now these two angles have to add up to 180. So 4x plus 60 equals 180. So 4x equals 120. So x has got to be 30. So at y is 50, x is 30. All right, these two have got to add up to 180. So if a quadrilateral is a parallelogram, the diagonals bisect each other. The converse of that is, or the inverse of that is true as well. If they bisect each other, then it's a parallelogram. So diagonals bisect. It doesn't mean all four are congruent. It means they bisect. It means these two are congruent and these two are congruent. Okay? So diagonals bisect. Bisect means cut in half, for those of you guys that forgot. Bisect literally means cut in half. So what they're saying is that if I've got diagonals that cut in half, it's a parallelogram. So if I'm taking a look here, negative 4x minus 2 equals negative 3x plus 4. All right, so plus 4x minus 4 minus 4. So x is going to equal negative 6. Y, on the other hand, flip that around. 3y minus 5 equals 2y plus 8. So y will equal 13. So all I did was algebra, subtract 2y, add 5. So that'll give me y equals 13. So find the values of x, y, z out of this situation. Well, let's start with this. Okay, for x, 5x is going to be equal to 27 because it's a parallelogram. So 5x equals 27. So if I divide by 5, x equals 5 2/5, or 5.4 if you really want the decimal answer. I don't like decimals, but knock yourself out. For y, those are diagonals. The diagonals bisect, so they cut in half. So 2y minus 5 equals y plus 4. So, a little bit of work, y equals 9, subtract y, add 5, y equals 9. Last is z, and here's where you get tricky. 3z is actually equal to 33. Here's why. If I've got parallel lines here, these angles are going to be alternate interior. So that means that they're going to be congruent. Well, if I look up here, those two are parallel. That's like a transversal. So 3z and 33 actually are congruent because they're alternate interior angles. So z is going to equal 11. So, final piece here. If one pair of opposite sides of a quadrilateral is both parallel and congruent, then the quadrilateral is a parallelogram. So, if you can somehow figure, show, prove that one pair of sides is parallel and congruent, then you can say, yeah, it's a parallelogram. Okay, but we have a quadrilateral. You don't know it's a parallelogram. If you can show these things, then yes, it's a parallelogram. All right, so do we have enough information to conclude if any of the following are parallelograms? For 5, congruent, yes, it's a parallelogram. For 6, 85, these are parallel. So you've got, or these are congruent, that's 85, that's 85. Yes, I would say, well, you don't have both sides and you don't have the other angle. You've only got one set of sides. But I would say yes. Here you got one pair of sides, congruent and parallel, so I would say yes. Here you've got 4 and 4, that's all you know, then I'm going to say no. Because I could have it 4 here, but this side could also be 4, but that definitely does not make a parallelogram. All right, so by the information, no, I don't have enough. So using coordinate geometry, if Q, R, S, and T, determine whether a quadrilateral for a parallelogram, justify your answer using slope. So slope is right here. So I want to look at the slopes of these things. All right, and I want to see if the slopes match up, or I want to see if two of them match up. So if I figure out my slope, so if I do QR, so that's going to be 3 minus 1 over negative 1 minus 3. So that'll be 2 over negative 4. So the slope of QR is negative 1/2. So 3 minus 1, negative 1 minus 3, 2, negative 4. All right, so if I take ST, 2, negative 3, 2, negative 1, 2, negative 3, 2, negative 1, so I'm going to go negative 3 minus negative 1 over 2 minus negative 2. So that's going to give me negative 2 over 4. So that'll be negative 1/2. So we know those two are congruent. So that means we're on a good start here. So here, if I want to figure out RS, I'll come over here. RS is going to be 1 minus negative 3 over 3 minus 2. So that's going to be 4 over 1, which will equal 4. So last piece, TQ. So if I do TQ, that's going to be, I'll do that down here, TQ, so if I go 3 minus negative 1 over negative 1 minus negative 2, that will give me 4 over negative 1. Let's check something. That gives me 3, let me double check, 3 minus negative 1, negative 1 minus negative 2. That gives me negative 4 right there. So these two do not match up. They are not both parallel. So the answer to my question is nope, because these two are not congruent. These two are fine, but these two are not. So that means I'm not going to have it be a parallelogram. All right, that's all I got. Come talk to me with questions, and we will talk to you soon.